Hi, I'm going to talk about iOS and Android. Android and iOS are the most popular operating systems using in mobile phones nowadays. Let's have a small comparison between these two operating systems. What is Android? Let's see a small description on Android. History of Android. It was first developed in 2003 by Android Incorporated. Development team consists of Nick Sayers, Chris White, Rich Miner and Andy Rubin. In 2005, Google stepped in to acquire the company, leaving Android Incorporated. On the 21st of October 2008, the first Android device was released. It was HTC's Dream, which is called as T-Mobile G1. Android is a Linux-based OS for mobile devices such as smartphones and tablets. Android comprises not only operating systems but also the middleware and the key applications. After the original releases, there have been number of updates in the original version of Android. Main idea behind the development of the Android was smarter mobile devices that are more aware of its owner's locations and preferences. Let's have a look about the Android versions. There are many versions of Android. Android 1.1, Android 1.5 Cupcake, Android 1.6 Donut, Android 2.0 Eclair, Android 2.2 Froyo, Android 2.3 Gingerbread, Android 3.0 Honeycomb, and there's a new version called Android 4.0 Ice Cream Sandwich. Android 1.1 introduced in February 9th of 2009. First launch device was T-Mobile G1. One of the most notable features of Android 1.1 was pull-down notification bar. The multiple home screen format was also introduced. Android market also came into existing at this time. Android 1.5 Cupcake. These all versions has very delicious names. This was introduced on 30th of April 2009. T-Mobile My Touch 3G phone was the first launching device. Improvements to the previous version. Introduction of copy and paste functions, camera functionality, keyboard inputs and methods, supported on the screen keyboards. Android 1.6 Donut. Released on September 15th of 2009. Improvements to the previous version. Support for the higher resolution screens was also implemented. Google search bar was greatly updated. Android 2.2 Froyo. Released on 20th of May 2010. Launch device HTC Nexus 1. These devices were co-created by Google. The previous version was improved by USB 3.3, mobile hotspot and Adobe Flash support was included, updated apps from the Android market, improved performance of the OS, Android 2.0, 2.1 Eclair. Released on 26th of October 2009. First launched on Motorola Droid. The previous version improved from free turn-by-turn navigation, improved OS keyboard, auto-correction capabilities and enhanced built-in camera functions, and live wallpapers. Android 2.3 Gingerbread. This was released on 6th of December 2010. First launched in Samsung Nexus S. This time manufactured by the Samsung. Improvements to the previous version was the user interface was updated, front-facing cameras were established, the drop-down notification bar was also improved. Android 3.0, the Honeycomb, released on 22nd of February 2011. First launched in Zoom Motorola. This was introduced specially for tablets. Improvements for the previous versions were multitasking, built-in apps were altered for the larger screens, Android 4.0 Ice Cream Sandwich. This is the latest version we have. Released on 19th of October 2010. First launched on Samsung Galaxy Nexus. There are lots of previous version improvements. Hardware buttons were replaced with navigational buttons. Google's Music app, enhanced camera function, single swipe panoramic photos. iOS. iOS developed by Apple Incorporated. This is Apple Incorporated's mobile operating system. Originally developed for the iPhone, it has since been extended to support other Apple Incorporated devices such as the iPod Touch, iPad and Apple TV. Unlike the Windows CE, that means mobile and phone, and Android, Apple does not license iOS for installation on an Apple hardware. iOS supported hardware devices, kernel type, hybrid, XNU type hardware supported. Initial released on 29th of June 2007. You can visit www.apple.com/iOS. There are few versions of iOS. iOS 1.x initial OS release, iOS 2.x second major OS release became available with the release of the iPhone 3G devices running. iPhone 1.x are upgradable to this version. iOS 3.x third major OS released became available with the iPhone 3GS. This release added much requested features such as copy and paste and MMS. Device running 2.x were upgradable to this firmware. iOS 4.x, fourth major OS release. This is the first major iOS release to drop support for some devices. The iPhone 3G and iPod Touch second generation have limited features, while the iPhone 4, iPhone 3GS, iPod Touch third and fourth generation have all features enabled. The iPhone and iPod Touch first generation cannot run iOS 4.0 and above. iPod compatibility was added with the release of iOS 4.2.1 on the November 22nd, 2010. iOS 5.x, fifth major OS release. This is also the second major iOS update to the drop support for the older devices. Apple Incorporated history. iOS belongs to the Apple Incorporated company. Steve Jobs is the co-founder, chairman and CEO of Apple Incorporated. He was born on 24th of February 1955 at San Francisco, California. His full name was Stephen Paul Jobs. He was died on 5th of October 2011 when he was aged of 56 at Palo Alto, California. The original logo with Isaac Newton under an apple tree. Apple logo in 1977 created by Rob Janoff with rainbow color theme used until 1998. The monochrome logo used since 1998. iOS programmed languages. First it was introduced in C, then C++, now it's in Objective-C. Objective-C is basically object-oriented C language. iOS Developer Center. You can visit this website for the more information. developer.apple.com/xcode/index.php. SDK history. On 17th of October 2007, in an open letter posted to Apple's Hot News weblog, Steve Jobs announced that the software development kit, that SDK, would be made available to third-party developers in February 2008. The SDK was released on 6th of March 2008 and allows developers to make applications for the iPhone and the iPod Touch as well as test them in the iPhone simulator. Xcode is the development environment for the iOS SDK. iPhone applications like Mac OS X are written in Objective-C. Android or iOS? Let's compare. A/B testing and preference testing. An A/B test is where you are presented with either A or B, not both, to see how you interact with it in isolation. When looking at the results, you get fair comparison between A and B, and thus have a fair idea of how two different designs are or interfaces compare. It's easy to judge which interface is the winner if it takes user a lot longer to interact with one than the other, or if they frequently select the wrong location or button for the simple task. A performance test has the two designs or interface side by side. This is bit more of the popularity contest, but in the interest of fairness, I have obscured the status bar, the bar at the top of both the iOS and Android apps in the preference test in order to try to eliminate people's personal preconceived preferences. When looking at the results, we can hopefully detect trend about which interface or designs people prefer. I know there are many people out there firmly on one side or other side. This debate could hopefully this test might help you to reconsider your preconceived notions. The test and results. For each apps in the test, I tried to think of very simple common tasks that people might be trying to perform. If it works out that people take roughly the same amount of the time to complete each task, it works out that there is huge difference between the two platforms or even from app to app. Then we can start from some judgments about what is going right or wrong, which platform is more or less usable. On the questions and results, the Twitter app. How would you view your at messages? If you are a Twitter user, and even you are not, you are probably familiar with the at message protocol. For those who aren't, at messages are the method you use for contacting other users on Twitter. For example, if you wanted to contact me, you could send a message to me at Sasika. As a very simple, very common task, this should really take no time to complete. As it's the first question in the test, we might expect people to take a few seconds longer as they are familiarizing themselves with the interface. The results for both the Android and iOS versions were very similar. The most surprising thing here was the amount of people who clicked the direct message button instead of that add button. Google Translate. How would you change the target language from German to another language? Changing language is obviously core piece of functionality for translation app and should be quick, easy to do. Let's see what the results show. Again, quite similar results. The Android version had slowest response time at the time of writing by 2 seconds, possibly because of addition of the arrows drop down, but also had slightly bigger spread of results, more or less tie or these two. Google Translate. How would you listen to the German audio pronunciation? This is one of the really handy features of the Google Translate app. You can make it to talk you into tone of different languages. Extremely useful when you are traveling or trying to learn new language. And common tasks with app. This is first time at the time writing that there is a bit more of a spread in the results. The Android app has longer click time, average of 12 seconds, but an 8% success rate, whereas the iOS app had average click time of 6.42 seconds but only 52% success rate. Regardless of click time, 52% success rate isn't nearly high enough, and so Android version wins the battle. The Android app speaker icon must be clear to most users. Facebook, which interface do you prefer? Another preference test with an app that the most would be familiar with. Facebook has made couple of changes between two apps, and it will interesting to see the results about the difference. Definitely, the majority supports the iOS version of the Facebook app here. I wonder how much of this because they already familiar with design. The final results was 74% for iOS and 26% for the Android. A win for iOS. How would you view your friend requests? Facebook is all about the friends, so accepting friends request is core functionality for the app. It may only make few seconds difference, but every part of user experience counts. And extremely close results here. Any of the selected areas allowed you to view your friend request considering the results of the part of the second. I am going to call this one tie. What does it all mean? So the final results in Android 9 and iOS 7.5. What we can conclude through is that Android iOS very similar in terms of usability, at least in the app we have tested. Of course, there are apps on the both platforms that are really very well designed and apps which should never have been let into the store market. Neither platform is immune to poorly designed apps. One difference that also need to be considered as part of the user experience is hardware, and this is where some issue come to fore. Although you can buy very high quality Android phones, you can also buy very cheap, very poorly designed phones which can cause terrible UX. One thing you have to admit about Apple is that their hardware is very high as well designed quality. Regardless, this test shows that the right hardware and the software combination both of the mobile operating systems can shine, and really which you choose can come down to personal preference without worrying about huge gap between two platforms. Either way, you should be happy camper. Android vs iOS. How secure are they? Both Android and iOS have traditional access control, such as password and idle time screen locking to protect the device itself. Isolation, limiting a processor's ability to access sensitive data or system resource from another process. Permission-based access control, granting each application set of permissions that limits of access to the specified devices at the systems. Limited hardware access, apps cannot directly access the underlying hardware. The hardware interactions are all controlled exclusively by the number of different layers of the software which act as the intermediaries between the applications and the device itself. Resistance to web-based attacks. Both systems have some built-in capabilities to resist web-based attacks. However, methods of application distribution. Android has more distribution channels. With the Android, there are more opportunities and methods to load applications. For example, Android devices supports more than one app store as well as large-scale over-the-air app distribution. iOS apps can only be distributed through the Apple App Store. Data encryption available on both devices. There are different levels of encryption, and some of them are device specific, and OSs provided mechanisms for the apps to store secrets in the ciphertext on disk, but apps don't always take advantage of these features. For example, data encrypted on your mobile device may be stored in plain text if you sync to a PC. Application security testing. The level of verification on app security isn't the same between the various Android marketplaces. Apple's app security and privacy are not thoroughly tested, and unauthorized access to sensitive data has already occurred in both App Store and Android marketplace. Apple has an approval process to place an application into the iTunes Store. However, it's not hard to find examples of apps being removed from the store after they have been found to behave badly. Android security features. Permission-based access control. Android's access control models is different than iOS's. Inside the application manifest, there is static list of permissions that the Android application requested upfront. The user presented with the list of applications. Installation time. Installing applications. The official Google Marketplace remote installation of applications to your phone. It prompts the phone to accept the installation. Therefore, it is not possible to remotely install and run and auto-erase the Find Me type application. iOS security features. Permission-based access control. When an application requested the use of the protected feature in the iOS, such as accessing the user current location at runtime, the OS pops up the dialog box in the middle of the app and asks the user if he or she chooses to allow the application access to the resource. Many apps fail if the user chooses no. Geolocation. Locates your phone when it's lost. This feature is provided Apple as feature of its operating system and accompanying online service. Auto erase. If your phone is lost or stolen, you can wipe sensitive data from your phone. It is even that the phone is returned, you can restore the information from your backups of the desktop. When its feature is enabled, 10 failed passcode attempts will automatically erase data from the device. Android weaknesses example. Android orphans. Millions of Android phones that are still under contract cannot be updated to the latest version of the Android OS. While West Application Marketplace. The application marketplace has limited, if any, security implementation. Instead, Google chose to allow nearly an application presented to the market to the published user consumption. Google does not check the security of the application prior generally availability. Smartphone manufacturers can modify the phone UI. Google Android is designed to be modified by the carrier releasing the device, but of the Android devices suffer from the additional of the software and UI modifications that the smartphone owner doesn't want or need. iOS weaknesses example. Every iOS device running at iOS lower than version 4.3.5 is vulnerable to flare called SSL MITM, which can exploit easily. Since Apple won't allow certain device categories to be upgraded to this level, it means that there are millions of permanently exploitable devices out there. Android has a similar problem. If an iPhone owner chooses to jailbreak their phone, he became more vulnerable to the malware. iPhone jailbreaks exploit security holes that may be closed that also be exploited by hackers. One example was located in the iPhone PDF parser, which contains a flaw that allows documenter to execute code. User satisfaction comparison based on app category. Stuff users hate. Crash comparison. Android application development. Basically, for the Android application development, we use Eclipse IDE, and we need Android SDK and Android emulator or an Android mobile device to test the application. iOS application development. Basically, it needs Xcode IDE, an iOS SDK, and iOS simulator or iOS mobile device to test the application. Android development, Android manifest, resource XML, Java source, generated class, Android libraries, Java compiler, .dex file, Delvic VM. iOS development, Xcode, interface builder, Objective-C source, .xib file, foundation framework, libraries, Objective-C compiler, simulator or device. Thank you for listening to our research. See you.